Hello everyone, welcome back to LMG. Today we'll be covering some good maths questions from Allen AIOT test series. And today we are going to take up questions from calculus. So let us begin. The first question says that the smaller area bounded by the circle x square plus y square is equal to 2 and y is equal to f of x above x axis, where fx is polynomial of least degree satisfying limit x tending to 0, 1 plus fx by x cube whole raised to power 1 by x is equal to e. Okay, so this is a nice question which is combining limits with area under the graph. So first let us analyze this relationship, because first we need to find fx so that we can find the area enclosed by these two functions. To find fx, we will expand or analyze this relationship. So it is given that the limit x tending to 0 of 1 plus fx by x cube raised to the power 1 by x is equal to e. So this is something like the form 1 raised to power infinity, right? And if this has a finite value e, then this value must be tending to 0. Why? Because if fx by x cube does not tend to 0, then if fx by x cube is greater than 0, then this will be of the form 2 raised to power infinity or something 1 greater than 1 raised to power infinity, which becomes infinity. And if fx by x cube is less than 0, then it will be 0.5 raised to the power infinity. 0.5 and 2 are just examples. This thing might be anything which is smaller than 1, right? Because fx by x cube is less than 0. So this will automatically tend to 0, or if the negative thing is even greater than 1, even greater than -1, or -2, then it might also tend to minus infinity. So for finite value e, limit x tending to 0, fx by x cube must tend to 0, right? So this is the first condition. So for that, fx must be of the form a4 multiplied by x raised to power 4 plus a5, x raised to power 5 plus a6, x raised to power 6, and so on. Because if fx has smaller terms than x raised to power 4, like x raised to power 3, x raised to power 3, then a3 x cube by x cube, this will become a3, right, which is a constant. Or if it has something even smaller than the power 3, like a2x square, then a2x square by x cube, this will become a2 by x, and since x is tending to 0, this will become infinity, right? And this is also not equal to 0. So our fx must be of this form only, and we are given that the polynomial must be of the least degree. So we'll find out that fx is equal to a4 x4, right? X raised to power 4, because it has to be of the least degree. So this is our polynomial. Okay, so we have found out that fx must be equal to a4 multiplied by x raised to power 4. Now we need to find the value of a4 also, because we have to find out the exact value of the function fx, right? So now let us analyze this whole thing. Till now we have only analyzed this fx by x cube must tend to 0, right? From that we found out that it is a4 x raised to power 4. Now we can analyze the entire LHS and RHS of this relationship. So we know that whenever we have something of the form limit x tending to 0, 1 plus gx raised to the power hx. Then the solution can be found out as limit e raised to the power limit x tending to 0, gx hx, right? So we'll use the same formula here. So e raised to the power a4x4 by x cube multiplied by this power 1 by x. This must be equal to the RHS, which is given as e. So this whole exponent should be equal to 1, right? Sorry, this 4 is in subscript. So x4 will get cancelled from numerator and denominator, and from here we will get that a4 is equal to 1. So fx is equal to x raised to the power 4. Okay, so now we need to find the area bounded by this function and this function. So let us plot the functions. It will be something of this form. X square plus y square is equal to 2 is a circle with radius root 2 and centered at origin. And x raised to the power is something like this. And we need to find the smaller area above the x-axis. So this we need to find, right? Because this is a smaller area bounded by this function and the circle. So for this we will need to integrate. So sorry, let me integrate here. So if we subtract the y of this circle with this y, we'll get and integrate it from where they are intersecting, then we will get the area that we need to find. So first we need to find the intersection points. So if I put y as x raised to the power 4 here, I will get x square plus x raised to the power 8 is equal to 2. So this equation is of the power 8 and power 2 also, so it would be very difficult to solve it algebraically. So we can easily guess the roots. Since the power are even, then x is equal to 1 and minus 1 would satisfy this. And since this is a symmetric graph, so we can find the area from 0 to 1 and multiply it by 2, right? So our final answer would be, so y of this circle can be given as 2 minus x square whole root, right? If we take this on the RHS, so 2 minus x square minus of x raised to the power 4 dx from 0 to 1 multiplied by 2. This would be our answer. So if you solve this, this comes out as pi by 2 plus 3 by 5. So the correct answer would be option B. So this was a nice question. The integration is fairly simple. It is given in the NCERT also, but realizing that this has to tend to 0 and then using this formula might be a bit tricky. This formula, it contains multiple steps. That's what makes this question a bit difficult. So let us move on to the next question. So the next question is a question from functional equations. It says that consider a function from positive real numbers to positive real numbers such that this expression is given and f of 1 is equal to 2 and fx is greater than x for all x belonging to positive real numbers. So initial conditions are given and some expression is given. So we need to find f of 9. So whenever we have a functional equation, we try to form cluster of functions which have the same format. You'll get what I'm trying to say when I start solving this question. So first of all, we need to realize that there is a bracket here. So let us first expand this. So f square x plus f square y minus 2xy is equal to f square x plus y plus 2x fx minus 2x f of x plus y plus 2y f of y minus 2y f of x plus y. Right, this is what we have been given. And if you see, then this f square x and f square y are given, and also 2x fx and 2y fy are given. So it is suggesting that something of a plus b whole square should be forming here. But x square and y square are missing. Also, you can see that the same kind of terms are given for this x plus y thing. So I'll try to form a plus b whole square type of things, or a minus b whole square type of things, because this will become minus when I bring it here. So f square x, first let me add x square plus y square on both sides. Right, so x square plus y square I have added on my own. So this would become f square x plus x square minus 2x fx. Similarly for f square y plus y square minus of 2y fy. So this is LHS completed, and this 2xy does not belong here because we cannot include it in any bracket. So let us take this here. So we'll get f square x plus y plus 2xy minus 2x f of x plus y minus 2y f of x plus y plus x square plus y square. Right. So this is suggesting that there would have been an x plus y thing which is being squared, because x square plus y square plus 2xy is given. But there are additional terms also, minus 2x fx plus y minus 2y fx plus y, right? So this is suggesting that something of this form is given. So on the LHS it is quite evident that fx minus x whole square was there, plus f of y minus y whole square was there, and here something like this is here. Right. So if you see, then the terms inside the bracket have the same pattern, right? That whatever is in the bracket of f function, that is being subtracted from it, right? So if I take fx minus x as gx, then we have been given that gx plus gy is equal to g of x plus y. Why I have written in this form? Because we already know the solution to this. So the solution to these kinds of functional is that gx is equal to k of x, right? So k of x is equal to f of x minus x whole square, because that is what g of x was. So then in such type of questions we need to put the initial values. So f of 1 is given as 2. So f of 1, that means that if we put x as 1, then this should be 2. So k multiplied by 1 is equal to 2 minus 1 whole square. So this will be 1. So this gives us k is equal to 1, right? So we get that f of x minus x whole square is equal to x, right? So if I take the square root, so f of x minus x is equal to root x, right? Which gives us f of x is equal to root of x plus x. So if I put 9 here, which I have to find, so I will get f of 9 is equal to 3 plus 9, which is equal to 12. So the answer is 12. So this was a moderate question from functional equations. These kinds of questions are usually found in test series, so you should practice them. So moving on to the next question. So the next question is a fairly simple question from limits. So the limit x tending to 2 of this expression is equal to. So first let us see what is happening at 2. So this will be root of 9, which is 3, and this will be minus 3 times root of 1. So the numerator is 0, and denominator would be cube root of 8, which is 2, minus 2 times cube root of 1, which is 1. So denominator is also equal to 0. So in such questions where we have 0 by 0 form, we can apply the L'Hopital rule. So we'll take the differentiation of the numerator and differentiation of denominator. So we will get 1 by 2 times root of x plus 7 minus 3 by 2 root of 2x minus 3, and there will be an extra 2 here because this 2x minus 3 also has to be differentiated by chain rule, and in the denominator we will be having, so this is 1 by raised to the power 1 by 3, so 1 by 3 times x plus 6 raised to the power minus 2 by 3 minus 2 times 3x minus 5 raised to the power minus 2 by 3 multiplied by 3. So if we put 2 in this, we will get 1 by 2 times 3 minus 3 into 2 by 2 into, this would be 1, divided by 1 by 3 of multiplied by 8 raised to the power minus 2 by 3 minus 2. So this would be 1 multiplied by 3. So let us simplify this. 2 and 2 gets cancelled. So this will be 1 by 6 minus 3 divided by 1 by 3 multiplied by 1 by 4 minus 6, which would give us minus 17 by 6 divided by 1 minus 6 times 12, which is 1 minus 72 by 12. So we will finally get minus 17 by 6 multiplied by 12 by minus 71. Sorry, we missed a 1 by 3 here, so this would be 3 by 3, which would make this minus 2. So this would be instead 24, which would give us minus 23 over here. So this gives us minus 34 by 23 as the answer, which is option A. So this was an easy question. Moving on to the next question. So this question, if you have not seen before, this might be a bit tricky, but if you have seen this, this will be easy, because in such type of questions we try to form tan and sec, right, whenever we have fraction powers of sec and cosec. So first we'll convert it into sine and cos. So whenever you have sec and cosec, it is always recommended to convert into sine and cos because it makes it easier to solve the question. So this will be cos raised to the power 4 by 9 theta and sine raised to the power 14 by 9 theta d theta. So this would become d theta divided by sine. We have to form tan and sec, right? So I'll try to divide this by cos raised to the power 14 by 9 theta, because that will give us tan 14 by 9 theta, and also this will become cos 18 by 9 theta, right, which will give us sec square theta in the numerator. Let us see. So I form tan using this, and I'm left with cos theta raised to the power 4 by 9 multiplied by cos theta raised to the power 14 by 9. So let us simplify this. I will get d theta. This would be cos square theta, which will become sec square theta in the numerator. And this will be tan raised to the power 14 by 9 theta. So if I put tan theta as t, then the differentiation of tan theta is sec square theta. That's why we have converted into tan and sec. So dt by t raised to the power 14 by 9 we have to find, right? And this is very simple because this is dt, t raised to the power minus 14 by 9. This would be equal to t raised to the power minus 5 by 9 divided by minus 5 by 9, which will give us the answer as option B. So the next question is also a question from integration. So if in, which is defined as the integration of ln x raised to the power n dx, then we need to find I10 plus 10 times I9, right? So in such questions where I subscript n is given, we often use the by parts formula, because that in the second term it gives us a term which is equal to what we already have in in, right? And that when we take on the LHS we get a relationship. In such questions we always use by parts relationship, right? So let us see. So in is given as ln x raised to power n dx, and if you apply by parts on this, so the first function is 1 and the second function is ln x raised to power n, right? So we will get x multiplied by ln x raised to power n minus of x, and now we need to differentiate this. So n times ln x raised to power n minus 1, and then we differentiate ln x by using chain rule. So by x dx. So x and x gets cancelled, and this n is a constant. So what we have is n multiplied by I n minus 1, right? So in becomes equal to x ln x minus n times ln x integration of ln x raised to power n minus 1 dx, which is basically replacing this n as n minus 1. So this will become I of n minus 1. So this gives us I of n plus n times I of n minus 1 is equal to x multiplied by ln x raised to power n. So now if we put n is equal to 10, which is what we need to find, so we will get I10 plus 10 of 10 times I9 is equal to x ln x raised to the power 10 plus c. I forgot the integration constant. So this is equal to option A. So A is the correct answer. So the next question is a bit tricky. Let the integration of dx divided by x plus 1 multiplied by x plus 2 multiplied by x plus 3 so on till x plus 10 is equal to summation of I from 1 to 10 a of I ln x plus I plus c. Okay, so this is the result of this integration, and ai is the coefficient of this ln x plus I, right? So if the summation from I is equal to 1 to 10 of ai multiplied by minus 1 raised to power I plus 1, so this ai we are summing from I to 10, 1 to 10, and we are also multiplying it with minus 1 raised to power I plus 1. So this is equal to 2 raised to power m by m factorial. So we need to find the value of m. Okay, so first let us try solving this using partial fractions. So integration of dx x plus 1, x plus 2, so on till x plus 10. So this would be something like a1 by x plus 1 plus a2 by x plus 2 plus a3 by x plus 3, so on till a10 by x plus 10, right? So for a1 we need to, if we take the LCM, then this a1 would be having x plus 2, x plus 3, so on till x plus 10, right? And the denominator would be having everything, x plus 1, x plus 2, so on till x plus 10, right? And so on for every term. A2 will be having everything except x plus 2 in the numerator. A3 will have everything except x plus 3 in the numerator. So if we put x is equal to minus 1, then all these terms will vanish, right? Because they will be having x plus 1 in the numerator, and on putting minus 1, x plus 1 will become 0, except this a1, because this does not have x plus 1 in the numerator. So, and this denominator will get cancelled from RHS and LHS. So, a1 would be equal to, sorry, a1 multiplied by, so if we put minus 1, this will be 1, this will be 2, and so on till 9 is equal to 1, right? Because 1 is remaining in the LHS. So a1 will become 1 by 9 factorial. For a2, we put x as minus 2, right? So a2 would be having x plus 1, x plus 3, we skipped x plus 2, right? Because it won't be having x plus 2 when we take the LCM. X plus 4, and so on till x plus 10. So if we put x is equal to minus 2 here, we will get a2 is equal to 1 by minus 1, 1, 2, 3, so on till 8, right? And also see that the summation is giving something of the form 2 raised to power m, which is the result when we sum binomial coefficients, right? So this question has something to do with binomial coefficients, which is evident from 2 raised to power m, right? And we need to have the same denominator also everywhere, which is m factorial. So I'll try to make this denominator a factorial. So what, this had 9 factorial, so this also must be 9 factorial. So I'll multiply it by 9 and this also by 9. So this would be minus of 9 by 9 factorial. Similarly, for a3, I will get, if I put x is equal to minus 3, then we will get a3, which would be a3 is equal to 9 by, so we will have x plus 1. So on putting minus 3 and x plus 1, we will get minus 2, then minus 1. Then x plus 3 won't be here, x plus 4 will give us 1, 2, and so on till x plus 10, which will give us 7. So here, sorry, this was 1. So here 8 and 9 are missing, and there is extra 2. So I need to multiply it by 8 by 2 and 9 to make it 9 factorial in the denominator, right? And this would be 8 by 2 multiplied by 9. So this is 8 multiplied by 9 by 2 by 9 factorial, right? So see, there is a relationship that we already discussed, that the numerator must be something related to binomial coefficients. So this is 9c0, this is 9c1, and this is 9c2, right? So similarly, we can predict that for a4, we will get a4 is equal to 9c3 by 9 factorial, and there would be a minus sign because a2 also had a minus sign. So the even subscripts will have a minus sign and odd subscripts will be positive. So then we have to find the summation. So see, if we put 1, then for odd terms there will be 1, and for even terms this will be minus 1. And even term already had a minus sign with ai, right? So minus minus will transform into plus. So what we'll be finally left with is, so this summation would give us 9c0 plus 9c1 plus 9c2, so on till So this subscript gives us a lower subscript in the C, right? So 10 will give us 9C9, and this would be divided by 9 factorial. And we know that this numerator is equal to 2 raised to power 9, right? We know by the formulae we learnt in binomial coefficients. So this will be 2 raised to power 9 by 9 factorial. And on solving this, we get 4 by 2835. So this was the answer for this question. And the final answer would be 9. So these were some good questions from Allen AIOT from calculus. Calculus has many chapters, so we tried to cover most of the chapters from calculus. So let me know if these kinds of videos are helpful for you and what to upload in the future. So don't forget to like and subscribe everyone. We'll meet in the next video. Bye.